Hello, Algebra 1 friends. Happy first ever e-learning day. I can't wait to hear what you guys think about this. I think it's almost like if you had a sub. You're still learning, but kind of like at your own pace, watching videos. I know it's not as awesome as seeing me and being able to ask those questions. So what I want you to do as you go through these notes is think of any questions you want to talk about tomorrow, because that's how I'll start on Thursday. Okay? So we are going to our packet from yesterday. If you lost it, I did email it out in the attachment so that you can use it on Notability and then just print it out. It is the third page, so it starts with day 9 and 10. We're only going to do day 9 because that's what Wednesday's plan was. So first thing I want you to do is pause the video, because one thing that's not going away is these exponent properties. So I want you to try these by yourself and then replay the video or play the video and check your answers. But don't rob yourself of the opportunity to practice. So go ahead and pause, and I'll see you in a little bit. All right, let's see how we did. So first thing on letter A, I'm going to put a little 1 there so I remember 4 is actually to the power of 1. So first thing I'm going to do in my small process is share. So 4 is going to be to the -3, because power to a power I multiply. And 0 times 3 is still 0. Okay, nothing I'm multiplying. Then I'm going to adjust my negatives, but if I look, y to the 0 is just a 1. So I'm going to have 4 to the -3rd. That is being raised to a negative exponent, so I'm going to move it to the bottom so it can become positive. And then 4 times 4 times 4, 64. Okay, next one, I'm going to share, nothing to share. Then I'm going to multiply, nothing to be multiplied. So now I'm going to adjust my negatives. And when we say negatives, we're talking about exponents. So that -3 is actually staying put. The only thing I'm moving is the d squared. Okay, and then I'm going to leave my leftovers. So I'm dividing a few things. Ooh, wait, just kidding. Those can be combined. I got too excited for the dividing. It's probably one of my favorite ones. Okay. So several things I'm dividing. I'm dividing -3 divided by 6, which if I cover up my variables, remember that's my strategy for you. It's just -1/2. You don't have to write the 1. Okay. The other thing I'm dividing is those c's. So remember, when you divide, you subtract. 1 minus 1, 0. So those are canceled out. And then my d, well, I should write that in blue. D to the 6. Boom. There's my final answer. All right, so hopefully you're feeling confident with those exponent properties. I'm going to keep throwing them at you throughout the rest of the unit because we still use them, especially tomorrow, but sometimes we kind of forget about them. So I'm here to remind you. All right. Next part, Ava. So now we're diving into key features, which is tying into yesterday and Friday. So Ava receives 2 different job offers. She uses the equations to work out her salary for the next 6 years at each. So here's one equation. Here's the other. And I want you just for a moment, think about what patterns do you notice happening? What comparisons do you see between these 2 tables and these 2 equations? Because that's what we're really going to explore today. Okay. So both job offers start with a salary of $40,000. There's 2 ways I could have known that. One, my y-intercept from the table. Or remember when we were doing the sugar in the workout? Your starting amount was always that first value. So I'm going to call that the y-intercept. So I'm kind of cluing into what key feature did you actually look at. Okay. In option 1, so job 1, Ava would earn a raise of what percent? So if I look, my percent is always told by my base. So 1.03 as a percent is 103. And we always compare back to 100. So that's a raise of 3% each year. Which I guess I didn't have to write the percent sign because it's there for me. Now it gets tricky because of option 2. If I convert that to a percent, it's still 103, which is 3%. So it looks like the same, but if I look at these tables, those are not the same value, right? At year 1, in job 1, she's making the 41,200. But at job 2, she's making more than that. So what is going on? If I look at my Y values, my salaries for both, do you see how year 1 is the same thing as actually year 2? And year 2 is the same thing as year 4. Oh, shoot, there's a typo, friends. Those should actually be identical. I apologize for that. That snow, 47 is the same thing as 6. So if I look at this, it's actually happening twice as much in my second job. So she doesn't just get the 3% once, she gets it 2 times a year. And that's where this exponent matters. If I said this out loud, it would be 2 times x. Well, what is x representing? X is representing the number of years. So she's really getting it 2 times a year. Okay, so let's see what you can tell me about a third job. So Ava was offered a third job. Go Ava, 3 jobs. Her annual salary for the job is given by the equation y sub 2 is equal to 35,000 times 1.03 to the 12x, where x represents the number of years. Describe what you know about this third job offer. So go ahead and pause. What do you know about this third job offer? All right. So you should be talking about every single number. 1, 2, 3. So that 35 at the beginning is talking about the starting salary, and we're always going to answer these in complete sentences. Okay, so the starting salary was $35,000. Then we want to talk about if it's increasing or decreasing, which is shown by your base. Okay, remember, once we convert that to a percent, 103%, is that growing from 100 or decaying from 100? So that is actually growing because it's bigger than 100. So I want to make sure that I include the word increase. So her salary is going to increase 3%. The last thing tells me how often is that going to happen. So since it's 12 times x, and x is the number of years, it's going to happen 12 times a year, which you can actually say a different way. If I think about what happens 12 times a year, months. So you could say monthly. If I say monthly, that's 12 times a year. If I say 12 times a year, that's monthly. So either way, your preference, what would you like to say? But make sure you're talking about every single number. Okay. Now, what about Michelle? Michelle strained her knee in a volleyball game. Aww. Her doctor has 2 options for anti-inflammatory drugs to help prescribe to reduce the swelling. So we've got option number 1, option number 2. Made some tables. So if I look, both medications start with a dose of 220 milligrams, which if I look is coming from that starting amount, that y-intercept, whatever you want to look at, but start feeling comfortable because we remove the tables pretty soon. Okay? So, option 1, the amount of drug in the system would increase or decrease. So if I look at my y values, as the x's increase, those are going down. I could have also told that from my equation. 0.97 is the same thing as 97%. We always compare back to 100. So it's decreasing because it's smaller. By what percent? Well, 97% is 3% away from 100. Now, how often is that happening? Well, since my x does not have a number with it, it's just one time an hour, because x is hours now. So every hour, or you can say one time an hour. In option 2, so if I look at option 2, I still have a decrease. And it's still by 3%. But what's the pattern now? If I look at 1 hour was 216.67. That didn't even happen in option number 1. It happened somewhere in between 0 and 1. Since 216 is between 220 and 213. So that didn't happen at all. 213, whoop, there it is, ties with the 2. 210 I don't see, 207 I do. So I'm looking for patterns. How long does it take for it to go down just 3%? All right, if I think about the second drug, this second drug is leaving her system way slower than the first one. So that fraction clues us in that it's actually a slower progression. So it's going to be every 2 hours. I want you to think for a second, how is that different than if I said 2 times an hour? So those are very different. 1 every 2 hours means it takes me 2 hours to do it just once. Twice an hour means in just a single hour, I've done it 2 times. So way quicker when you're multiplying, which makes sense because when I multiply a number that's going to get bigger, dividing, going to get smaller. It's going to take longer. Okay, so let's try this one, and this is actually where we stop. So this is your end of today, and then you work on homework number 9, and that's part of what I check tomorrow. So I'm going to check these notes that I talked through, and then homework number 9, and that's what's going to count as your attendance. Michelle's mom suggested to the doctor that she take another medicine that won't be in her system as long as the others. The equation y equals 220 times 0.97 to the x over 4 gives the amount of drug left in her system. Y after x hours. Is her mom correct? Why or why not? So go ahead, pause, try it, come back. All right, sorry, Mom, you're actually wrong. Because if I look at that equation, it's going to decrease every 4 hours. So it's going to take 4 hours just for her to lose 3%, versus the other one happened 3% every hour. All right, and that's all for today. Please remember, think of questions that you have. If you look at the practice underneath, would you feel comfortable doing those problems? If not, think about what stumps you, because that's going to be our warm-up tomorrow. And I can't wait to see you guys.